Hi everyone. In the earlier session we have seen fixed speed synchronous motor drives. In today's session we'll see the variable speed synchronous motor drives. In that there are mainly two types. One is true synchronous mode, another one is self-controlled mode. This true synchronous mode will work in open loop drives. That means it is more or less it is like a open loop drive. So there is no feedback in true synchronous mode, whereas in self-controlled synchronous mode we need to take the rotor position as a feedback and DC link current as a feedback, and we can automatically control by using the V by F ratio control we can go for the self-controlled mode. So here in true synchronous mode the stator frequency is controlled independently. That means we will give the reference frequency, and as per the reference frequency your output frequency of the VSI inverter or input to the synchronous motor will be controlled. So your stator frequency is independently controlled based on your reference frequency, whereas in self-controlled synchronous mode the stator frequency is controlled by the rotor position feedback. So we need to take the rotor position, that means indirectly we will take the speed as a feedback and we can control the speed in this self-controlled synchronous mode. So we'll see one by one. So coming to the true synchronous mode, here we'll use a V by F controlled synchronous motor. So how do we use that V by F? V by F is nothing but flux is directly proportional to the V by F, right? Voltage ratio of the voltage and frequency is directly proportional to the flux. So indirectly we are controlling the flux to control the speed torque characteristics. Coming to the block diagram of this drive, so here three-phase AC supply is three lines means three-phase AC supply. It is given to the control rectifier. The control rectifier is connected to the voltage source inverter through the DC link inductor and capacitor. DC link inductor and capacitor to remove the harmonics or to filter out the harmonics in the DC link current and voltage. We will use this inductor and capacitor, and that is connected to the voltage source inverter. The output of the voltage source inverter is connected to the, because here we are using the three-phase voltage source inverter, that's why we will get the three-phase AC as a output. The corresponding frequency is nothing but fundamental frequency to the synchronous motor. Here multiple synchronous motors are connected in parallel: synchronous motor 1, synchronous motor 2, synchronous motor 3. So you can connect the multiple synchronous motors with three-phase AC supply. And as this is open loop mode, we need to give somewhere your frequency as a reference, and that frequency, corresponding to that frequency, your firing angle need to be given to the control rectifier, so that your frequency need to be adjusted at the output of the VSI corresponding to the reference frequency. So to get that one, so here we will give the F star is nothing but reference frequency. This reference frequency is given in step mode, but the step mode frequency directly should not be given to the VSI, voltage source inverter. So for that reason we will use the delay circuit, so that instead of instant change in the frequency it will make some delay, so that the corresponding actual frequency will go to the voltage source inverter. That much frequency we need to get at the output. So to get that one, we need to control the rectifier output voltage, so that we can get the required voltage also along with the frequency corresponding to this actual frequency by using this V by F function generator. V by F function generator duty is corresponding to the frequency will get the voltage. So if you are providing the voltage to this V by F function generator, it will give the voltage corresponding to this input frequency. So that is treated as a voltage, and the corresponding voltage will be given to the triggering circuit. So the triggering circuit need to generate the firing angle alpha to the 6 control switches in the control rectifier, because three-phase AC supply means control rectifier will have 6 firing pulses, right, which will be displaced with 60 degrees angle. Firing pulses are displaced with 60 degrees angle. If we know the first firing pulse position, then the remaining firing pulses will be displaced with 60 degrees. So the corresponding firing pulses will be generated by using this triggering circuit. For this triggering circuit, the reference voltage will be getting from this again a reference frequency only. Based on this reference frequency, voltage will be generated. Based on the reference voltage, the firing angle will be generated. That will control the output voltage, which will be given to the input as a voltage source inverter. The output of the voltage source inverter is also three-phase AC supply. The AC supply is controlled with frequency. So the frequency will be generated as per the reference frequency, and that will be provided to the synchronous motor drives. So here only one problem with this open loop drive or true synchronous mode, that is it will give more unstable as well as it will give haunting oscillations. Okay, but coming to overcome that, we need to go for the other mode, that is nothing but self control mode, where you will get the closed loop synchronous motor drive. So here if you see the speed torque characteristics for this particular drive, on y-axis I have considered the speed, on x-axis torque. So in the speed torque characteristics, earlier in the fixed speed synchronous motor drives, for the fixed frequency we got one speed, and corresponding to the torque will be varied. So that's what we have seen in the previous sessions. So but here we are changing the frequency. We can control the frequency by changing the reference frequency. We can control the frequency of the synchronous motor drive. When you are changing the frequency, the corresponding speed of the synchronous motor drive will change. Let us assume at F1 frequency, these are the speed torque characteristics. If you are changing the frequency, if you are increasing the frequency, the speed torque characteristic will shift upward. F1 is less than, F2 is less than, F3 is less than F4. That means we are increasing the frequency. When you are increasing the frequency, the characteristics will shift upward. This maximum torque based on the load angle will get this maximum torque. This T maximum will get from 0 to pi by 2 angle, when plus pi by 2 angle when you are changing the load, or torque angle when you are increasing from 0 to pi by 2, your torque will change from 0 to T max. If your torque angle is varying between the 0 to minus pi by 2, the torque is changing from 0 to minus T max. But how the speed will change? To change the speed, we need to change the frequency. The frequency variation is we are getting by providing the reference frequency. That's why for F1 frequency, these are the characteristics. The maximum limits are given here as T max and minus T max, F2, F3, F4. Up to rated speed, the torque, maximum negative torque as well as maximum torque are fixed. Constant torque. So that's why this is constant torque region. But beyond that, if you are increasing the frequency, because here we are maintaining the V by F ratio as constant. Here V by F function generator is there. V by F ratio is maintained constant till the rated speed. So that when you are increasing the frequency, you need to increase the voltage to keep the flux as constant, so that torque will be constant in the V by F ratio control. So but beyond rated voltage, we cannot increase the voltage beyond its rated voltage, because to avoid the insulation failure or to avoid the protection for the windings, we should not increase the voltage beyond its rated voltage. So beyond its rated voltage or beyond rated speed, till the rated speed we are applying the rated voltage. So till the time we are increasing the frequency corresponding to the increase variation in the voltage, V by F ratio is maintained constant. But beyond this we need to increase the voltage beyond rated voltage, because at rated voltage we got the rated speed. So beyond that, if you are increasing the frequency, your voltage should be kept constant. Voltage should be kept constant to avoid the insulation failure of the winding. So only frequency is varying. In the V by F ratio control, only frequency is increasing, whereas voltage is kept constant. So by that, the corresponding flux or field will decrease, right? When field will decrease, when field or flux is decreasing, the corresponding torque will decrease. earlier minus Tmax and plus Tmax, that is maintain constant. That's why this is constant torque region. Whereas here, as you're increasing the frequency beyond its rated voltage, F5 is less than F6, is less than F7, is less than F8, because we are increasing the frequency from F1 to F8. As you are increasing the frequency, your field is decreasing. That's why this is called the field weakening zone. When your field is weakening, that means if your field is weakening or flux is decreasing, so here speed, if you see the torque will also decrease. It will maintain between these dotted lines. Both positive maximum torque as well as the negative maximum torque will decrease because of the decrease in the flux. So as torque is decreasing and speed is increasing, so because frequency is increasing means speed is increasing. So power P is equal to omega into T, right? So as torque is decreasing from minus Tmax to less than minus Tmax, less than, still less than, because if you see the corresponding value on the x-axis, that is decreasing. So as torque is decreasing, but as frequency is increasing, your speed is increasing. So power will be constant. That's why in the field weakening zone, that is considered as the constant power zone. Constant power zone. So in this way, for the variable frequencies, we'll get the variable speed torque characteristics in both motoring mode as well as the braking mode. Motoring mode will get by varying the del angle between 0 to pi by 2. For the variation of del angle, torque angle between 0 to minus pi by 2, will get the braking characteristics. So these are for motoring mode. Motoring mode, in the first quadrant, when we get the negative torque, that is nothing but braking mode, which you'll get in the second quadrant. So this is all about the true synchronous mode variable speed synchronous motor drive. Okay, thank you all.